All right. So thanks everyone for tuning in. We are super happy to welcome you today for this new webinar session. The topic of the day is how to easily secure your cloud native applications, and we will study that security point of view through the Traefik prism. So Traefik EE is an enterprise solution based on Traefik open source, the famous edge router. And my name is Adrian. I am the sales manager for Containers, and I am today with my colleague Manuel.
Hi.
Manuel is our solution architect and is a long-time Traefik maintainer. So we are super stoked to have Manuel with us today for this presentation and quick demo of how to easily secure your applications. So the agenda for today is the following. So the duration of the webinar is limited to 30 minutes. So the idea is to have a very a quick presentation of the main concept, quick demo, and then we'll have some 5 minutes to take all the questions that you may have during the session. So we will first explain how to easily activate the HTTPS for your backend and your services leveraging the Let's Encrypt integration. And this is something very easy to do, with Traefik, and that's why many people, love Traefik because of the ability to manage and review automatically the certificates. So Manuel will explain you that in a minute. In second, we will see how we can leverage what we call middlewares and so far distributed middlewares in order to tune the requests that are getting inside your cluster. And for example, if you want to limit the number of connections to a certain services or microservices, we will see how it is possible and easily doable with our stack. In third, we will show you and explain you how we can easily export the logs, the metrics, and the traces from Traefik into the best of breed toolings like, for example, Prometheus, Grafana, Kibana, or Jagger and Zipkin for the tracing. And point number 4, we will show you a super nice feature of Traefik Enterprise, which is a backup and restore. And finally, we will show you the high-level architecture of the solution, and we will do a quick demo to show you how easy it is to launch, all these security-related features. If you have any questions during the sessions, feel free to type them in the Q&A sections that you will see at the bottom of your screen, and don't hesitate to type them as soon as they are coming to your mind, and we will take them in 20 minutes approximately. So without further ado, I am now handing over to Manuel.
All right, I will grab over the screen then. Thanks a lot. Here we go. So that should be seeable. As Adrian already mentioned, that's our five points we will try to go over today. And yeah, I will start with the first, which is encrypt the connection you have going over to your microservices. To just encrypt the connection, the web connection, you would use something which is called HTTPS, which is basically the combination of HTTP and TLS, whereas TLS stands for Transport Layer Security. What this does, it like as the name is suggesting, it encrypts really the connection from your browser to your desired microservice or to your load balancer or proxy in front, essentially. For that to work, TLS requires a valid, which means signed certificate, to prove that this is valid what you're doing. So you have it's usually signed to either a domain or people, like real people, and yeah, it just gives some trust, let's say. That certificates are usually given out by something that is called certificate authority. So you mostly have to pay like the certificate authority to sign you a certificate that you can use. Then that gives your, like, you know, the green bar in the browsers usually. Um, However, since a couple of years, there is an open source certificate authority called Let's Encrypt, which provides this TLS certificates for free. The cool thing about that is that that it's fully automated and fully open source, so you can write all your nasty scripts or all your automation to receive that certificates for you, to renew their certificates for you, to basically take over all their certificate handling you need to do. And it does it then for free, because like the certificate authority doesn't take money for it. So that's basically the point of connection encryption and why it's important. Because let's say you have you're an e-commerce shop and you're taking credit card numbers of your paying customers. You really don't want to have these very sensible information transported over an unencrypted wire, so that everyone could just read the credit card numbers of your potential customers. So that's no good. Therefore, yeah, you really want to encrypt. You really want to encrypt your connections. When you have already the connection itself secured, let's say by, for example, TLS, the next logical step is to control how much of this traffic really flows and what it does essentially. This is important because by controlling the traffic flow or the amount of traffic you have, you can you can spare your services from being overloaded. Let's say you have this payment microservice running somewhere in your application, and you don't want it to die, because if it dies, you may get into real troubles. For maybe some credit card bookings weren't fully completed, so maybe your system thinks it did do it did book the amount of your customer's credit card, but in reality it did not book it. So yeah, there's really some room to lose money essentially in that scenario. And that's something that you really don't want to have, and that you need to take care of, that this really doesn't happen. And therefore there are a couple of best practices or well-known patterns to do that. And two of these are rate limiting and open connections. They help you controlling how much of traffic, or how much of the traffic actually you have. In the rate limiting scenario, for example, you can say how many requests per second a desired service, let's say your payment microservice, is eligible to receive and is okay to receive. So you can set a number which is like an upper border, let's say, where you know, okay, my service will be fine handling that given amount of traffic, and just don't over exceed it, because their service might be dying. Essentially, the same goes for open connections. It's just a bit different. So especially with HTTP and stuff, the browser is keeping open a connection to your backend, let's say, and yeah, with that metric, you can basically limit the amount of open connections you have to your service. And yeah, so to also make sure to not, or at least try to not kill it by being overloaded. The third, the next logical step, let's say, is monitoring, because you already have like your connection secured, and you can control the traffic flow, let's say. So you now need to have the opportunity, the possibility to see if all what you did is really working out, and that's where monitoring comes into play. These days, monitoring is separated into two major parts. The first of it, you could summarize it as observability. So that's basically check how your application is doing, and that's usually done currently with by having a look at two different paths. One of it is metrics. That's basically all the technical information your infrastructure and your application might be emitting. So too many requests per second, for example, or a desired microservice took too much memory, or all that sort of stuff. But of course, also there is logs, which is like which could be error reports your application have written, and all of that has really be taken to like a close eye on it, because on this metrics, let's say what you check there, you can react. Let's say you have events like too many requests per second, or you have an elevated error rate reporting or something. So that's something to react on. Your monitoring system could alert you, saying, well, there's just too much memory use. There are too many errors in a given application. And once this event happened, you might want to check what caused this, and that's where the second part comes into, which you could summarize as traceability, which is basically checking what your application is doing instead of how it's doing. And with it gets and the good way to have that is if your whole traces your application might have, so the inner circles, the inner doings of your application, are also connected to what is happening from the outside, starting from your load balancer, because by having that, you can see the full request lifecycle of like what happened when the HTTP GET request, for example, really started to hitting the edge of my infrastructure and went through to my desired microservice and did some Redis calls or MySQL queries or whatever. And then you can really dig down and debug and see what might be the cause for your elaborated error rates, for example. So by seeing all of that, you gain a whole lot in terms of security of your microservice, because you see what's going on and you can react on certain occasions. So last but not least, from the 4 major bullet points we defined, the last is obviously backups and restore. I guess we can all agree on that. Backups are crucial for your business to ensure that no data is getting lost. And basically everyone has backups, but it can happen that you don't test if they are really recoverable, and you really test your disaster recovery process to make sure that that really works the way you want it to work. Because I mean, it's good to have backups, but if all your backups are corrupted or your recovery process doesn't work, that's just not helping you, because you don't get the data back. So you really have to ensure that. And therefore, good advice is, as usual, just do it both regularly. Not just do the backups, but also test your recovery process in a certain scenario, in a certain environment, and make sure that all of that is working flawlessly. To ensure that no data is getting lost if you really run in that disaster scenario and you need to recover data. So first, you good from my side. So I will, for a second, pass over to you, Adrian.
Yes, thank you, Manuel. Yeah, and don't hesitate to ask the questions again on the Q&A sections right at the bottom. So let me share again for this slide. Okay, so now that we've seen, the 4 different pillars that we can easily activate in order to secure your microservices applications, let's now do a quick focus on the solution that we're going to use to do so right now. So some of you are aware about Traefik, the famous ingress controller that now has more than 1 billion and 300 millions of downloads, which is quite amazing for a young open source project that is only 4 years old. Let's now talk about Traefik EE, which is the production grade and clustered version based on Traefik open source. So in this architecture, you now see a distinction between what we call proxies and controllers on the other side. The proxies are really, the nodes that will take the HTTPS request from the internet and route them towards the right backends in real time. And the controller itself has the responsibility to discuss with your orchestrator, for example, Kubernetes or Swarm, but it can also be like a Consul or etcd, like a service discovery tool, for example. And the idea with that is, since there is only one controller being aware of that, of all the configuration files from a certain clusters of containers, it can then share this configuration in a certain manner to the different proxies. And that's very, a distributed architecture in the sense that you can then scale the number of proxies and without the need of scaling the number of controllers, and then you can basically route more traffic to more microservices. The controllers, the Traefik key controllers itself is discussing as well with Let's Encrypt, and it can store in itself. There is a little KV store that allows you to store your ACME certificates, and the controllers will then discuss and answer to the challenges proposed by Let's Encrypt. For example, the DNS challenges. So Let's Encrypt will challenge, an HTTPS certificate in order to see if it's still valid, or if a user has the right to access it. And that will be centrally managed by the Traefik key controllers. And last but not least, there are what we call the distributed middlewares. And for example, and Manuel already touched on that a few minutes ago, but let's say you really want to secure the instance 1 on the service A, or let's say even like service A, so it means both instance 1 and instance 2. You can set a maximum number of connections per second for these backends, and the controller, the Traefik key controller, is aware of that. So let's say you put 100 requests per second maximum, then the first Traefik key proxy will let go of 50 requests, the second 50 requests, and then the controller says stop. Now, among the proxy, you don't have the right to pass any more requests to this backend. So in a very simple manner, that's how we can explain to you what is a distributed middleware. So to summarize, Traefik EE is the clustered and production grade based on Traefik open source. There is a distributed sharing of the configuration file. This is what's here on the auto discovery and then shared to the proxy. Then there is the Let's Encrypt overall management, done by the controllers as well and shared to all the proxies. And then we have what we say the distributed middleware also. So this is the very high level architecture. If you have any questions regarding that, feel free to ask some more questions. And I will now hand over to Manuel that will quickly show you some stuff with Traefik E.
All right, thanks a lot for that, Adrian. I will quickly make this a bit larger so that you can actually see what I'm doing. What I will show you is now, and I will quickly just go to the slides for that. I want to show you on the local Kubernetes running K3s, basically the 4 pillars we already mentioned within our talk so far. The first is obviously an installation of Traefik E because it's super quickly done. Then I want to show you HTTPS and Let's Encrypt, how we can back up and restore a cluster. I want to show you the distributed middlewares and going and metrics and tracing, just to show you how that can be done easily. For that, I will quickly install Traefik E, which just will take probably half a minute or so, because we have, as you might know, we have this utility which is called Traefik E CTL, which makes sure that we can fully control the installation process, and for that I will keep that running. Once that is done, I will quickly deploy the tools we need to do all the showcasing we have. So a Pebble as local certificate authority to make sure that that we can request Let's Encrypt certificates locally. A bit of monitoring for Grafana and Jaeger and all of that. And yeah, that's basically it. So while that being installed, there we go. The data node is already, the control plane is already up. So the data node should be in a minute as well, or in a second actually. And then we are good to go. Dim 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 dim. Always those demo effects. There we go. So Traefik EE is installed as wished, let's say. So I will quickly apply all the tools we need for monitoring and all that. So that's good as well. So just to show you that I really have something to see, I quickly deployed the web application, which should be up in a second. While that is going, we can quickly check the dashboard of Traefik EE. So yeah, this is still coming up. So the container, here we go. So that's the container. That's the application I have deployed. So that's good. Within Traefik EE, we have also an own tab for metrics. So we could check what metrics this application is currently having. There we see a lot of 503 from the boot up process. Once that refreshed, here we go, we will see a lots of 404, so we know something is going on with our application. And going back to the application, because that's the only one we deployed, we can see in the network tab that this is causing all of that because it's trying to reach a couple of microservices that are just not there yet, resulting in the 404. So to get that away, I will quickly deploy this microservices in order to get the error gone. They are now deployed, so within the next seconds we should see some cities arriving here. Here we go: Paris, New York, San Francisco. So all of the microservices are now answering correctly. And that being said, with the next refresh of our metrics tab here, the 404 requests will stay where they are and the 200s will rise eventually. So that's a resolved issue, and we were able to react really, really fast on that one. So we have that monitoring aspect already done, let's say. For the next part, which is the connection encryption, we will make sure to use Let's Encrypt for that. Traefik EE has a command built in which is called acme add account, which basically sets some default values for the Let's Encrypt process. So what I want to do is I want to customize the certificate authority server to use, because I want to use a local one. So I just add the defaults. It will connect to the Traefik EE control API and make sure that all of this is set. And then the only thing needed is to actually change the configuration of Traefik EE to make use of that. So I will activate the Let's Encrypt activation integration with that, and I tell him, hell, please request a Let's Encrypt certificate for the domain webapp.docker.localhost. And also to show you the monitoring and tracing, I will also activate both of them while I just change the configuration. So I press enter, and that is going to work out. So if we quickly, for while it fetches the certificates, we can quickly have a look at how he's doing basically. And how he does that is the control plane now, the Traefik EE control plane, as this is the controller of the whole cluster, is requesting their certificate. And as we can see, it started to request their certificate already. It tries to solve the challenge, in that case, the HTTP 01 challenge, and the server already validated our request. And now the server also already responded with their certificate, which is now being delivered automatically to all of our data nodes, so to the actual proxies. So if I now go here for HTTPS, we will see the warning, which is fine because it's a self-signed certificate by Pebble. But if we check the certificate, we really see that it's a Pebble intermediate certificate, so from our offline certificate authority, and that it's good. Without the default settings, he would now have contacted Let's Encrypt, but that's a little hard to go there from a local environment. So that worked perfectly. As we did some stuff and we see that there is some requests still being emitted, we will quickly have a look at the Grafana, which is the view of our Prometheus metrics. And there we can see that we see all of the web metrics Traefik EE sees. So we can, for example, check the latency globally. We can check the per node latency. we can see the backend total requests over 1 minute period to like see if one of our services is getting too much requests, to potentially then enable rate limiting or other scenarios to make that sure. So, and let's say one of our services here is just getting too much of requests, and we want it to limit it. Then we could go in our ingress definition of Kubernetes and just set a couple of annotations to make that sure. In that scenario, we would set a rate limit for the Paris microservice, which would be over a period of 1 second. It should have 2 requests per second in average. And I just do this to 3 to make it fast sooner. And I allow him to burst up to 5 requests per second. So if I reapply these configuration and therefore the microservices, we should really soon see Paris failing. There it was already because it disconnected. And if we check for one of the 4 to 9 requests, we can see that it's request blocked by rate limiting, please wait. And yeah, so that kind of works. Resetting that basically will Paris back, and all is good to go. So that's good. Last but not least for the Kubernetes, because that's a part we mentioned as a pillar as well, it is important to be able to back up and restore your scenarios. So for that, we also have a command built into Traefik EECTL, which is called backup, and we just give it a cluster name, and then the backup process backups the whole installation, as you can see, including Let's Encrypt certificates. So if I then quickly uninstall my cluster and yeah, make it go, and then recall the install command, but instead of what I did previously, I now give it an archive path to the backup the command just created to 911 to 911. I'm too bad to type today, I'm sorry. So I will quickly grab this. Dim. So, and I present her again. He will now restore the cluster as I previously backupped it from the exact same state with the exact same configuration, including all Let's Encrypt certificates. So once the installation is done, which should be within the next couple of seconds, we can go back to our web application we deployed previously, and yeah, and just see it working with the certificate. So the installation is done. He's now restoring the certificate. There we go. So that's all restored. If we go back to the dashboard, we see that it will be there in a second. Yeah, for the dashboard, yeah, that's true. But if we go here for the web application, and I call it over HTTPS, and we check the certificate again, we see that it's still the intermediate signed certificate that we requested 5 minutes ago. So the whole backup process worked. With that being said, before I pass it over to Adrian again, because we are running out of time, just so you know that we also, if you, for example, are not running a Kubernetes, but instead you're running, let's say, on Docker Swarm, maybe even with Docker EE, Traefik EE offers more security features. For example, in that scenario, we could install Traefik EE on a swarm, on a Docker EE swarm, but by passing it a UCP bundle, which is basically the control plane of Docker EE, Traefik would not have to mount the Docker socket or something to query the Docker API. Instead, it would reuse this UCP for this. And by that, it would be possible to run Traefik EE not only on Swarm Manager nodes, but only on Swarm Worker nodes, which reduces threat because no one needs to mount the Docker socket anymore, but instead you pass that job over to Docker EE handling all of that. So with that being said, I pass it over to you.
Thank you, Manuel. So, and thanks for this great demo showing the Traefik EE capabilities inside a K3s cluster, which is a very light version of Kubernetes for those who don't know K3s. Yeah, so if you have any questions, for the moment I don't see any, so it means that this is clear to you. So if you have any questions coming after the presentations, feel free to email us at sales@container.us, for example. Or if you have questions on the on the community edition, we do have a place for you to ask these questions, which is community.container.us, and this is where the community goes in order to thank you, Manuel, for showing this final slide. So you can go on that if you have questions on the open source, and if you want to try the EE edition, you just go on container.us/TraefikEE, and you can request your 30 days free trial. And if you have any technical questions also, Manuel and I or any other people from the team will be happy to jump on a call and a dedicated session with you. That being said, thanks everyone for tuning in today. We're super happy to show you this presentation, and we'll see each other very soon. Bye-bye.
Bye-bye. Take care.